mean, I started on this type of investigation when I was 19 years old, and now I'm 72. And now I'm just beginning to understand a lot of this stuff in great detail. But when I perfected the first SERPs circuit, which is what we call a switched energy resonance power supply, I was totally blown away by what happened with it, because the interesting thing is you can measure with two very sophisticated watt meters the fact that there's more power developed in the load than there is taken from the line. And everybody will tell you can't do that. It's totally impossible. It's a violation of thermodynamics and electrodynamics and conservation of energy and all this garbage. But actually, it isn't. And so I knew at an early age, when I started discovering this stuff, that Tesla had found something that put him on a different track than everybody else was on. And I said, okay, we come to this planet to do something, to accomplish something, to learn something. I'm going to dedicate my life to try and rediscover what that guy knew. And he talks about a discovery of a device that he could build, which today would be interpreted as a flying saucer. And he knew exactly what gravity was because he had discovered it in the meaning of it in Colorado Springs when he was out there. I was building automation systems for tugboats and oil barges and stuff like that in New York, Boston, and Baltimore. And I did all my own programming. I even designed all the equipment and installed it on three separate fleets of tugboats and ships.
This episode of the podcast is brought to you by Onnit.com, ONNIT.com. Onnit is all about total human optimization. Check out a product called Power Food Active. It's awesome. It's the optimal fuel source for pretty much everybody. It combines protein for your muscles and a host of micronutrients to support your body. It is power food at its finest. It's also ridiculously delicious in shakes, smoothies, coffees, and even food recipes. It's a perfect complement to any lifestyle. So yeah, use this formula as a part of your daily regimen to maintain optimal performance. It's got a balanced amino acid profile, and it represents one of the most nutritious and energetically favorable plant-based proteins available. So the ingredients is it's decadent chocolate flavor. It comes from pure cacao, and it's enhanced by one of the most sought-after performance foods in the world, maca. It yields 5 grams of plant protein from organic hemp, organic brown rice, and peas. It contains a balanced amino acid profile on both essential fatty acids, the essential omega-3 and omega-6, as well as omega-9. It's deliciously sweetened with stevia and monk fruit, which are low glycemic sweeteners. It's high fiber blend, and it makes insanely delicious smoothies. So, yeah, it's pretty amazing, and gluten-free, soy-free, dairy-free, and vegan. So check it out. Onnit.com, ONNIT.com. Enter code Philosophical Minds at checkout to receive up to 10% off any and all supplements.
The future is a concept. It doesn't exist. As the proverb says, tomorrow never comes. There is no such thing as tomorrow. There never will be, because time is always now.
Welcome to the Philosophical Minds podcast, the podcast about the stuff we wonder about
and other things.
Our guest today is Jim Murray, engineer, inventor, entrepreneur, lecturer. He has ran hundreds of experiments on electrical phenomena. He's fascinating. He got his start in nuclear physics in high school, where he developed his own linear electron accelerator. Jim, how did you develop such a strong interest in all this?
My best to answer it. I mean, it happened over a series of years. It wasn't just a kind of a instantaneous change, you know. But I've had an interest in electricity since I was a child. And I can still remember, even as a kid, I used to stick pins and things into the electric sockets and, you know, wasn't afraid of getting the shocks. And I was fascinated with this invisible agent that can do so many things. But my first real utilization of electricity was actually with my dad's train sets. He had them stored away for years, and I had taken them out of the closets, you know, as a kid, and just instinctively knew how to hook stuff up. And he was pretty amazed about that. And, of course, I loved the trains for what they were, but secretly I was really dying to understand more about the electricity that ran them. And so I just started doing different experiments. I remember some of my first ones were with homemade electromagnets and things like that. I used to save my pennies and go down to the hardware store in Jersey City and buy these great big old-fashioned 1.5 volt dry cells and wind coils around nails and stuff like that, and, you know, turn them on and off and pick things up with them. And all those invisible forces just were amazing to me.
Uh-huh.
So as I got older, I started playing with bigger and bigger things, you know. I started messing around with motors and associated control circuits and things of that sort. And, of course, I didn't live too far away from the Hudson River, and down there was a lot of tugboats and marine equipment, and I used to go on board some of them and look at all their generators and the old-fashioned slate panels and just all kinds of things like that. And so over the years, I just automatically decided I was going to study electricity, and I went through high school taking all scientific courses, and I won a lot of stuff in science awards and science fair projects. I won two very pronounced awards in New England for my school and city and state, and I wound up having my projects on display at the Boston Museum of Science for a month and won a grant for doing all that. And I think I was in the sophomore year for the first one and the junior year for the second one. And I had intentions of doing other stuff in my senior year, but unfortunately my dad died of a heart attack, and so I had plans of going to MIT, but that didn't develop. And so I had to earn money to put myself through higher education. And after Dad died and I finished graduating high school, I started school nights, but college, that is. But in order to earn an income, I went and signed up working in the local shipyard. And first job I had was just scraping hulls and getting the barnacles off, things like that. And then eventually they found out I had some mechanical abilities, and so I became a diesel mechanic for a while. And sooner or later I made friends with the head of the electrical department, and that's where I wound up working. And that's when I really got exposure to a lot of exciting things. DC motors, 2,000 horsepower, and all kinds of generators and control systems, transformers, rotary converters. God almighty, you name it, I did it.
Wow, yeah, and I believe you hold many patents now as well for some of your inventions. Do you want to talk about some of your inventions? I think you have one called the transforming generator. What was the purpose of that machine?
Well, actually, I invented that initially to explore the difference between voltage and EMF. And most people just use them interchangeably, but actually they're not the same. And I wanted to understand in great detail the difference between those things and what I could do with them. And so one of the key ingredients in a generator, of course, are the windings. And most windings in modern generators are either skein windings or wave windings. But intuitively, I wanted to play around with toroidal windings because they have other properties. And so I invented this machine, or designed this machine, that used two toroidal windings and an energized rotor. And I started experimenting with that, and then I discovered through that particular embodiment that this machine had really strange properties. It had the obvious capabilities of generating power because you had a rotating field moving through these toroidal windings. But then when you put a load on the machine, the windings basically communicated with each other and changed the source impedance. And so as a result of that, it actually put out a greater amount of voltage when I had a load on it than it did when it was unloaded, which is very different from a normal generator. And it had a number of other really exciting properties to it. And so once I had time to really investigate them and make notes and whatnot, I realized how different it was. And so I applied for my very first patent. The interesting thing was it was granted in France and England and declined in the United States.
Surprising. So what did you end up finding? What did you discover? What is the difference between electromotive force and voltage?
Well, there's actually a lot of differences, but the one that's the most easy to describe, especially on the phone, is the obvious difference that even though people use the two expressions interchangeably, EMF is actually what you might call emotional voltage. It's produced by a magnetic field being in motion. And as a result of that, it's a true electromotive force that's produced. And that force, in turn, can give rise to a current. And then, of course, you can pass the current through various impedances, and that does all kinds of different things depending on what your circuit is like. But a voltage is actually that phenomenon which is created by passing a current through an impedance. So an EMF is created by relative motion either of a conductor through a magnetic field or a magnetic field through a conductor, or else a time-varying magnetic field. But a voltage, technically speaking, is actually created by a current passing through an impedance. And so they're not the same at all. They just happen to have the same units.
And then I know you had another one, I think it was called the SERPs, Switched Energy Resonant Power Supply. What was that?
Well, that's a difficult one to describe because actually it was the result of the various investigations that I did with the transforming generator, which resulted in another machine called the Dyna flux alternator. And the Dyna flux alternator was a very unusual device that didn't have a cylindrical rotor. It actually had a rotor that was shaped like an ellipse. and that rotor allowed that machine to manipulate flux in a very peculiar way. And it took a lot of years to really understand that device and to investigate all the forces associated with it. But when I figured that I had it pretty well worked out, I wrote a patent and applied for it. And I don't remember what year it was. I think it was 1984 or somewhere around there. And it was unceremoniously rejected by the patent office for all kinds of different reasons. And I had to write rebuttals, educating them to the fact that the things that they were complaining about were totally legitimate principles in physics. And it took 4 years and thousands of dollars before they actually turned around and gave me the patent granted status. But in the meantime, while I was doing all of that, I realized how complicated the thing was. But on the other hand, I also understood some of the basic principles involved. And I said to myself, I wonder if these same principles could be used on the receiving end of power rather than the generating end, and thereby produce another effect or a similar effect so that people that had ordinary electrical power applied to their homes could get some benefit from applying this as a modifying agent to produce similar effects to the Dynaflux generator, but only in their homes. And so I began to experiment. My first experiments were actually all done with high-powered tubes, because I was actually raised in a time period when tubes were in vogue and transistors were just coming over the horizon. So I was pretty familiar with tubes, and I started experimenting with various principles involving tubes. The only problem was I got interesting results, but I couldn't produce enough amperage. Most tubes, unless you're talking about really heavy-duty industrial devices like ignitrons and stuff like that, they basically only deal with milliamps. And so even though I learned a lot from it, I really couldn't produce anything that controlled enough power to find out whether the device was worthwhile or not. But I kept on working with it, and over the years, as I was experimenting, solid-state devices were being perfected and put on the market, which allowed me to then upgrade the performance of this idea. And eventually, what happened was I figured out what I was trying to do and how to do it, and I produced an electronic circuit which imitated something that Tesla had talked about but never explained. As a matter of fact, a lot of people, even today, don't believe that he knew what he was talking about, and they have this horrible way of looking at Tesla's later claims by just writing it off to senility. And I guarantee you that guy was not senile.
Does this have to do with the Tesla power magnification?
Well, it all has to do with that, ultimately. That's the interesting thing. But the pathway to finding what it means and how to do it is very, very torturous and arduous. I mean, I started on this type of investigation when I was 19 years old. And now I'm 72. And now I'm just beginning to understand a lot of this stuff in great detail. And the reason for that is twofold. First of all, the way our society is set up, you have to earn a living in order to continue on and survive. And so I had to always have a job on my own, and then when I got married and had a family and a house and all that stuff, I had to do all that work just to make ends meet. And so my research, for the most part, became a hobby that I did in my spare time. I had my own machine shop in the basement. I had my own laboratory, had my own office. And I was very lucky that the girl I married was understanding. But, I mean, the way she looked at it was, well, I'm not carousing around. I'm not drinking. I'm not out with the guys every night. I'm home as soon as work is over, and I spend my time with the family. And then when the kids go to bed, I go to the lab,
Yeah.
So I guess she looked at it from a positive point of view. But anyway, as a result of doing all of that, I was making progress over the years and slowly discovering different things. But then, switching jobs and going to school and doing all these other things that I was doing, and always being shy of money, it just takes forever to accomplish anything. So, it took a lot of years before I started to really see the light. But when I perfected the first SERPs circuit, which is what we call a switched energy resonance power supply, I was totally blown away by what happened with it, because the interesting thing is you can measure with two very sophisticated watt meters the fact that there's more power developed in the load than there is taken from the line. And everybody will tell you can't do that. It's totally impossible. It's a violation of thermodynamics and electrodynamics and conservation of energy and all this garbage. But actually, it isn't. If you really understand what's happening, it doesn't violate anything. And this is the type of thing that Tesla understood intimately. And when he got tired of listening to everybody's negative feedback, he just stopped explaining stuff. He just went about his work using what he knew and, disregarding everybody else's complaints and concerns. And he accomplished miracles which were never understood. I mean, in 1889, Tesla was already producing in his laboratory in New York City. This is before he even went to Colorado or Long Island or anywhere else. He was producing discharges that had such a high voltage behind them that the sparks were 14 feet long.
Wow.
Now, it takes several thousand volts at ordinary air pressure just to do 1 inch. So you could almost figure out a percentage that would tell you how much voltage he was dealing with. Nobody knows how he did it, not even today, because the equipment just wasn't big enough, to explain the phenomenon that he was producing with what we know how to do now. I'm sure we could produce a 14-foot discharge, but it wouldn't be with some relatively small box. It would be with some gigantic piece of equipment. And so I knew at an early age, when I started discovering this stuff, that Tesla had found something that put him on a different track than everybody else was on. And I said, okay, we come to this planet to do something, to accomplish something, to learn something. I'm going to dedicate my life to try and rediscover what that guy knew. And as soon as I made up my mind, that's when all kinds of things started to happen. You know that old expression, when the student is ready, the teacher will appear?
Yeah.
Well, I got news for you. I had one teacher after another over the years, and the stuff that I've been involved with and the things I've seen blow your mind.
Wow.
Really, they would.
I want to talk about some of that stuff, but before that, I want to ask you, you discovered something called the power oscillation principle. Is that right?
Yeah, well, that's what I call it.
What exactly is that?
Well, I can tell you what it is, but don't ask me for an explanation, because to give you a verbal explanation over the phone, we'd be talking
difficult
for a month. But anyway, basically what it is this. Let's say that you have a power supply of a standard design, and you're using it to light a light bulb or run a toaster or whatever you want to do with it. So if you instrument that thing to look at what's really going on, you'll find that power moves from the source to the load, and that's it. So by standard reckoning, the power supply supplies wattage. The wattage goes and does work, which changes that power into something else, either heat or light or motion or whatever you're trying to do. And once it's used up, it's gone. So you have to take another swath of power out of the power supply to continue whatever the operation is. But the thing to remember is that all that power moves in one direction only, from source to load. So when I got more familiar with things like the Dynaflux generator and the SERPs device and things of that sort, I started to realize that there's something else going on which is not being utilized in the modern world, but obviously Tesla had made use of it in his world, which was one of the reasons why he could do things nobody else could do. And one of those things was this power oscillation concept. Now, what that means in simplified terms is that on the first part of the cycle, you borrow power from the power supply and you use it to run a load of some sort, and then you send power back from the load back to the source. And so your instruments behave completely differently than they do in the first circumstance. And you wind up with mathematical expressions which denote an inequality. And that's the kind of thing that makes most people crazy, especially physicists, because they don't understand what they're looking at. So getting back to that statement I made earlier concerning the SERPs, if you borrow 100 watts, let's say, from the line, and you send back a similar amount of power to the load, well, if you're monitoring the power in the load itself, you're going to see 200 watts registering, because the instruments don't care if the power is flowing from left to right or right to left. But the interesting thing is, whatever is monitoring the source is going to see VARs instead of watts, because you've got power going back where it came from. So if you were to actually plot that, what you see on the load is a wattage function that looks like a sine squared function sitting on an x-axis. But if you look at what's going back to the source and coming from the source, you would see a sinusoidal component that had symmetry with respect to the x-axis, top and bottom. So in other words, it has a negative component to it. So in the reactionary world, when you have a negative going component that's equal to the positive going component, that's referred to as reactive power, and it approximates an average value of 0. So the question becomes, well, how can you have 0 watts supplying power to 200 watts? It doesn't make any sense, because 0 doesn't equal 200. But that's not what's happening at all. That's just an ignoramus's interpretation. So these are the kinds of things Tesla did on a routine basis. And the interesting thing was he spent his entire career perfecting, understanding, and developing the mathematics behind all this stuff, which the man kept to himself. Wow. And then when he died, or actually it was even before he died, when all of this stuff, particularly the three-phase power stuff, hit the the U.S. market and other worldly markets, there were so many things implied in that mathematics that, first of all, the average engineer couldn't follow it, and second of all, the authorities, whoever they are, were terrified that secrets would eventually get out that would lead to free energy or some highly efficient form of energy that the power companies wouldn't be able to make a profit on. So the General Electric Company, which by that time was formed, and I think it was a combination of Edison and J.P. Morgan and somebody else, hired Steinmetz, and Steinmetz examined all of the Tesla stuff, and he was a brilliant little guy when it came to the mathematical end of things. And he rearranged all the equations to take the basic Tesla knowledge and present it in a way that was more simplified and made use of certain shortcuts. But once those were taught as dogma, they also prevented 99.9% of all the engineers from ever going beyond the accepted limits and coming up with a duplication of Tesla's stuff. And of course, once he died, they basically had things the way they wanted it, and with very, very few exceptions, nobody has ever gone back to look for whatever it was that Tesla had at his disposal compared to what is done today.
Yeah, I think
because they were all brainwashed.
Yeah. I think most people are familiar with Tesla and some of its history with AC current and rotational magnetic fields, but let's talk about some of the lesser talked about work with Tesla, for example, with his X-rays and robotics and vertical takeoff and landing, anti-gravity. What can you speak to about that kind of stuff?
Well, I could probably tell you a lot about all of those things, but before I do, let's stick with the first subject that you brought up about the three-phase motors and things of that sort, okay? The interesting thing there is if you go and look at Tesla's original patents and you look at the diagrams, never mind the description, but the diagrams themselves are very telling, because his first polyphase motors were two-phase. They were not three-phase. And the interesting thing is they were toroidally wound, just like my transforming generator. Now, the interesting thing is, all of a sudden, somewhere along the line, they started using skein windings and wave windings and all these modern windings, and everybody just accepted that without any challenge. Why are we doing this? And that was because they didn't have a detailed understanding of why Tesla did it that way in the first place. So all of that is lost information unless somebody's willing to put years into rediscovering the whole thing. Now, when it comes to X-rays, for instance, that was a natural thing for Tesla to get involved with because he was using particle accelerators powered by AC tandem accelerator devices. Very early on in his career. And, of course, he discovered around the same time as some of these other people, like Becquerel and what's the girl's name? Madame Curie and her husband. All of these invisible rays that were fogging photographic plates and what have you. The difference was that Tesla had such command on the power involved in these things that he could X-ray a human skull 50 feet away and make a photographic exposure of it, whereas most people had a tiny little bulb that they were playing around with and would have to get you right up close to the source, and even then they had a pretty crummy-looking picture. There's some early pictures of people's hands and things of that sort, but they were certainly not taken from 50 feet away. So this guy just had a natural facility for doing these type of things, and he just knew how to do it. Whether he was working intuitively or whether he was a total bloody genius or maybe he was reincarnated from Atlantean times, who the hell knows? Yeah. Now, the fact of the matter is you cannot dispute the fact that he did these things. It's a matter of record. But, you know, in America in particular, Thomas Edison is the guy that everybody emulates and everybody's excited about. And the establishment puts him on a pedestal, mostly because of the fact that he cooperated with the financial people and did everything exactly the way they wanted. And so he's their pretty boy inventor. And they don't want any part of Nikola Tesla. As a matter of fact, they tried to actually erase him from the record. If it hadn't been for a handful of Tesla enthusiasts that emerged back around the late 50s, early 60s, they might have even succeeded. But now, of course, everybody, or pretty much everybody, knows who he is. The biggest crime is the fact that they don't really know the extent to which he accomplished things. Now, as far as the vertical liftoff device, he has a patent on that many years ago, but it was basically another version of the Osprey, I think is what the Air Force calls it, where the wing and the motors tilt and the thing can take off vertically and then slowly twist the wing and go forward. It was something very similar to that. But that was not his pride and joy. He just did that because he wanted to. I mean, I don't think he even made one. But the other aspect of it that he talks about in a number of lectures, and I mean, I don't know where they are right now, but I have them. And he talks about a discovery of a device that he could build, which today would be interpreted as a flying saucer. And the interesting thing about it is that the earliest mentions that I know about this thing were somewhere around 1926, I think. And he came out with it in rebuttal to Einstein's theory of relativity, or maybe it was a special theory of relativity. I'm not clear on that. Well, Einstein basically explained gravity as a four-dimensional phenomenon which made use of the curvature of space to produce an extra force which propelled things, down toward the surface of the planet and also, attracted one piece of mass to another and all this stuff. And Tesla said that it was absolute rubbish. And he knew exactly what gravity was because he had discovered it in the meaning of it in Colorado Springs when he was out there by virtue of an accident. And it was the same accident that burned out the generator at the local power station that was selling him power. And he had to go and rewind that thing for them before they would reinstate him as a customer. But he never bothered to talk about what he discovered. He kept it to himself until he made that rebuttal to Einstein, in which he stated firmly that gravity was a resultant force that came from a true field effect. He knew what it was, and he had already experimented with it, but it wasn't on the top of his list. He wanted to get the Wardenclyffe Tower built first and make use of worldwide communications and the wireless transmission of power, at which point he said he'd be happy to transmit power to vehicles that made use of this artificial field structure. And we all know that he didn't do that for whatever reason. But the interesting thing is, he promised in 1926 or thereabout that he was going to publish his dynamic theory of gravity, which he expected would completely shoot down relativity. And mysteriously, he decided not to do it.
Wow.
And he never did.
Does that have something to do with the orgone energy?
I don't honestly know enough about orgone to tell you what the relationship might be in terms of that. But I think, and this is just my personal feeling, based on a lot of independent research, I think that what Tesla actually wound up doing was that he either passed some kind of information pertaining to gravitational effects to somebody else to take forward in time, or else something was actually stolen from him and taken forward in time, because the next time stuff like that manifested was actually in the early 50s. And the interesting thing is, the first guy that made mention of that I'm aware of, I mean, there could be others, was a guy by the name of Otis T. Carr. And Carr started a company in Baltimore, Maryland in 1950-something, 52 or 54, and it was called OTC Enterprises, and he raised millions of dollars to produce an anti-gravity vehicle, which he said could be used to travel to the planets and make a real success out of the space race and do all these other things. And when he was questioned about where he got this information, because he did not have a professional degree, he had gone to school to be I think it was some kind of a designer or something, and it didn't have anything to do with electromagnetics or, electricity or whatever. But his comment was that when he was working his way through school in New York, he was originally from, I forget where he was from. I think he was from somewhere in Pennsylvania or Ohio. But he had gone to New York to attend Brooklyn, one of the colleges in Brooklyn for art and design and stuff like that. But he had a temporary job as a package clerk in the Pennsylvania Hotel in New York City. And one of the things he was doing was delivering packages of peanuts and birdseed to Tesla's room, because Tesla had this mania for feeding the pigeons. And he used to go out in Bryant Park in the evenings and have hundreds of pigeons coming down to, eat the free meals that he was serving them. So eventually this guy Carr wanted to know what the heck this fellow was doing with all the birdseed and the pigeons and the peanuts and all of that stuff. And so I guess he asked around about what Tesla was all about, and somebody told him. And so over time, while delivering all these packages to Tesla, they became kind of friends. And that Tesla was pretty much a recluse, especially in his non-working hours. Well, I imagine he was lonely because he never married or anything. And to have this young guy be totally excited over his work, you know, I think it would be quite natural to just befriend him to some extent and start talking to him. So anyway, according to Carr, and I have never been able to verify this officially because I got in touch with Pennsylvania Hotel, and their records did not go back to 1926. So, and it had changed hands a couple of times and stuff like that. So nobody could prove that Otis Carr actually worked there. But according to Carr, he got information from Tesla, which allowed him to start this company in Baltimore, Maryland, in the 50s. And he basically hired a lot of people. He had engineers and stuff working for him. But he befriended this one guy who came to see him by the name of Gene Carini. And Carini was actually a TV repairman, but he was very talented in electronics. And he had an insatiable appetite for space and rockets and UFOs and aliens and all that kind of stuff. And to him, what Carr was doing in Baltimore was irresistible. And so he went down there and talked his way into a job, and he became Otis Carr's electronics expert. And after they left Baltimore, the company relocated in Oklahoma City, and they wound up, I guess, renting. I don't think they bought it. Some kind of an old aircraft hangar that was on an airfield that was just outside the limits of Oklahoma City at that time. And that's where they built the first OTCX-1 circular foil spacecraft. And they had all kinds of people came there to see this thing lift off. And they even had a Long John Neville was a guy who had an early nighttime show like Johnny Carson and the guys before him. But it wasn't so much comedy as it was unusual stuff, you know, unusual people. And it was like a talk show on the air, you know, and they investigated all kinds of things. And he was even there with his TV crew. And apparently, Carini and he had kind of a falling out over the way this thing should be wired and safety precautions that should have been taken and things of that nature. And make a long story short, instead of taking off, it blew up. And they had used mercury in some of the components on there, and apparently in quite large quantities for whatever reason. And the fumes from the mercury escaped out all over the place like this big gray fog. And people panicked and ran out of there, and Neville filmed the whole thing. And Otis Carr ran up on the stage or the launching platform or whatever it was, and pulled the switches himself to stop the thing, and he wound up with mercury poisoning and was hospitalized. And then the authorities moved in. I don't know what all they confiscated, but they grabbed everything they could out of there. And Carini quit and went back to his home in Connecticut to reestablish his business over there. And eventually Carr went to California to a place called Apple Valley, where he essentially restarted his company in a different state and went back to trying to build UFOs again. And I heard about this whole story from a guy by the name of Dominic Lucchesi. And Lucchesi, as it turned out, was mentioned in a book called They Knew Too Much About Flying Saucers by Gray Barker. And my girlfriend at the time gave me a copy of that I think it was for our anniversary, 1 year going together or something, because she knew I was interested in that sort of stuff. And when I read that book, I found out about this guy named Dominic Lucchesi who lived in the same city that I lived in. He was only a couple of miles away from me, and I couldn't believe it. So I went and became friends with him, and he was the one who first told me about this whole big episode with Otis Carr. And I made it my chosen task in life at that point to find this guy and find out everything I could about it and about this saucer and everything else that he was doing. And I won't give you the whole story because it's long-winded, but basically what happened was, as a result of my investigations, I met other people, and they didn't know about Carr, but they knew about a guy that was roaming around trying to raise funds for an unusual project, and his name was Gene Carini. And, of course, it was the same Carini that had worked with Carr. And so I looked this guy up in Connecticut, and a buddy of mine and I drove up there to meet him, and I had already been doing my own research on a lot of stuff, and, of course, I was basically in and out of college because of lack of money. And he got me at a time when I was going to night school, but he made me an offer that I couldn't refuse. He said, well, if you want money for college, come work for me, and you be director of research and development, and we'll work on this stuff together. And it turned out that he was working on an electric car, and this was in 1967. And the electric car was being powered by a totally different type of propulsion system, which Gene at the time told me was his invention. But I found out a long time later that actually he had more or less usurped that information from Otis Carr while he was working with him. And apparently it came out of a blue notebook, and that notebook, Carr never was without. He never left it anywhere. He never did anything without it. He was always consulting it. And according to Carini, who saw it a few times and actually had a chance to look through it at one point, there was no way that Carr did the work that was in that notebook because first of all, he might have been able to draw the sketches, but it was full of equations and diagrams and graphs and all kinds of stuff. And he knew Carr well enough to know that he couldn't have been the one that produced it. And many, many years later, and I won't go into it right now unless we've got time some other way, I learned from Carr himself that he had known Nikola Tesla personally. And then I found out just before Carini died that he had interviewed Otis Carr about his association with Tesla shortly after they first met. And I had the opportunity to listen to that interview on tape. And in there, Carr said things which led me to believe that he had gotten that blue notebook from Tesla.
Oh.
So there's so much going on behind the scenes, and apparently I'm only probably one of the last people that knows about all this stuff simply because of the fact that I had the audacity to track it all down and become a part of it, very early on in my career.
Yeah.
Many years later, when I moved to Las Vegas to work with another guy, I had the opportunity to meet Ralph Ring, who supposedly became involved with Tesla and the flying saucer work out in Apple Valley, California. And to be very honest with you, after listening to his story, knowing all about the details of the first construction from Carini, and having located Otis Carr in an old age home before he died and hearing his story, and there's other people involved as well, I absolutely don't believe a word of Ralph Ring in the things that he said about the saucer that they constructed and the things that they actually did. Because the technology that he described, which he apparently intimated that they had used in the 1950s and early 60s, was only perfected and put to use recently by the United States Air Force and the Russian Air Force. And nobody even knows the extent to which it's capable of operating. And there's no way that they had that then, because billions of dollars were spent to create that type of technology. And these guys, by their own admission, were working on shoestring budgets. So, you know, I could say a lot about all this stuff.
Yeah, and
detail, but today is not the day.
Did you ever get the opportunity to meet Otis Carr?
Yes, I did. I told you I met him in an old age home in Pittsburgh, but it was actually a little area outside of Pittsburgh. I forget what it was called. But yeah, I tracked him down, and I met him with a buddy of mine. We flew out there, and he lived on a street called Bracy Drive. And you know, I said before he was from Pittsburgh. I don't think so. And now that I remember, I think he was from West Virginia.
Okay.
But I could check that. You know, and it's a lot written on the subject.
What was he like?
Very, very weird. I mean, he knew stuff, okay, and you could tell that he knew things, but he knew them in a non-scientific way. He had the tendency to be a wordsmith in the way he presented stuff, that it was so mystical and so roundabout that he awed a lot of people with his words, but from the scientific point of view, he said very little in actuality. And he was a known drunk, which is unfortunate.
Mm-hmm.
He was a pudgy little guy. His hair was very thin and turning white when I met him. And his wife lived with him. And for some reason, he would never talk in front of her. It was really strange. We were sitting in the living room, and he was lecturing about all of his work with anti-gravity and all this other stuff and pre-energy things. And the wife walked through to go to the kitchen, and as soon as she opened the door, he quit talking. And as she walked through the room, and she was an older lady, so I mean, there wasn't any, haste in her steps. She just more or less pecked her way across the living room and into the kitchen. And he just silently followed her with his eyes and twisted his head. And he never said a word. And when she got into the kitchen, he just looked at us and he said, "That's the wife."
Strange.
I mean, he didn't introduce us or anything. And she was a lot more polite than he was. Eventually, she made soup and sandwiches, and she called us in there for lunch. And they were very cordial in that respect. But you could tell that there was some kind of a scission between them. I don't know what it was.
Whatever happened with Gene Carini?
Oh, a lot of things happened with Gene Carini. When I worked for him as Director of Research and Development, I was up there for about 2 years, maybe a little less, and he had several guys that had invested a lot of money in what he was doing, and one guy who was an Armenian was a gigantic pain in the ass, and he actually did more to impede progress than he did to assist in the way things were going. Anyway, we built 3 electric cars. One was a Volkswagen, one was a King Midget Racer, and the other was a Corvair. No, was it a Corvair? Yeah, I think it was a Corvair. And it had the motor in the back. So we took the motor out and put a battery box in there and put this propulsion system into the wheels of the car. And with the King Midget Racer, instead of putting it into the wheels, we put it into an isolated flywheel and put that in the back of the car. And with the Volkswagen, it was built into the wheels, but instead of using timing chains, he used belts, ordinary V-belts, and the thing had so much torque that the belt slipped, and so it was almost impossible to really test it for effectiveness. The King Midget worked the best, but the one that they were really basing their hopes on was the Corvair, because it was pretty much a standard-sized car. And so ultimately, I had a buddy of mine come down to be co-pilot, and I was the pilot, and we took this thing out on the road, and they had a regular, like a convoy or whatever you want to call it, that had the electric car in front and the company car in the middle with banners on both sides of it. It was a big tan Cadillac, I think, and then Gene Carini's personal car at the end of the procession with his flashing lights, to keep the traffic back from the experimental run. And the idea was to run from Gene's little town in Connecticut, where the research center was, all the way into Hartford. And, get it in all the newspapers and everything and raise millions of dollars and this and that and the other thing. And I had already warned them that it wasn't going to work because the math demonstrated to me that there was a problem. And the Armenian fellow was really annoyed with me because he felt that I was trying to sabotage the thing. But anyway, we went out on the road and did this, and we came to the first hill, which was called Andover Hill, and that wasn't too far away from where we started. And the damn thing started to pull so much current that as it went up the hill and slowed way down, and finally it stalled at the top of the hill, and it started rolling backwards. And so as not to hit the cars behind me, I swung over into the other lane to be at least going in the right direction, even though I was heading down the hill backwards. And right over the top of the hill when I did that came a gigantic semi. And he was only a few feet from from the hood of the car. And he was blowing his horn and trying to slow down and all this kind of stuff. And the first chance I got, I spun off the road, went through somebody's hedges, wound up on their front lawn. The battery box exploded, and there was a big fire in the car and all this kind of stuff. And that was just the beginning of the trouble. Then after that, the Armenian guy, who happened to be the treasurer, decided that he was going to get his investment back. So he wrote himself a check for $50,000, which of course is totally illegal. And the president of the company, who was not Gene, it was another guy, he was smart enough to say, well, what's in this for me? Because he had to countersign the check. And so the Armenian guy wrote a separate check for $10,000 for him. And the other guy, instead of cashing the check, he was honest. He went to the authorities and disclosed what the other guy had tried to do. And there was this huge legal mess, and the company got shut down, and Carini moved to Florida. He was going to retire anyway, so he moved to Florida, and I went back to school. But that was not the end of my association with Carini. I mean, I had many, many years of friendship with that guy and did a lot of other things with him. But, I mean, it would take hours and hours to explain all this. And not only that, there were other people. I tracked down that blue notebook. I tracked down all kinds of stuff that came out of all of that. And, eventually I got set up in my own corporation and started doing my own research, which was at least based, for the most part, on real facts. So it's been a very intriguing adventure.
Jeez, it's fascinating. Whatever happened with the majority of Tesla's work when he died? I've heard some claims that say Donald Trump's uncle got a hold of some of it, or others that most of his files were sent to Serbia. What's your take on all that?
Well, both of those statements are true, but to varying extents. First of all, and I'll say this because with a dubious extension to it, because I can't prove it. Hold on while I check my battery here.
Okay.
Yeah, we're okay for now. There's a certain category of individuals who have investigated Tesla for other reasons and in other directions, and they have come to the conclusion that he was actually murdered. And the reason why they say that was because he had written a letter to the United States government sometime in the last half or the last third of World War II, offering them his discovery of this ray weapon that he had developed. And they didn't accept the offer, but I understand that because he was broke and living on a pension from Yugoslavia at the time, he also sold some of his other stuff to other governments. I'm not sure which ones, but I know one of them was the Tesla turbine, and there may have been other devices like the vertical takeoff thing. And, the poor guy needed to survive, and nobody gave a damn. But I think that was looked upon with great disdain because of the fact that the war was going on. And I think that whatever the death ray weapon was, maybe he had second thoughts about it. Maybe he was communicated with on a private basis and refused to cooperate. At any rate, one story is that they killed him, and when they killed him, they took everything out of his file, which was in the safe in his office. In addition to that, however, and this is something I personally investigated, so I know more about it. Over the years, Tesla had generated so much data and so many experiments that he kept records on, that in a warehouse in Brooklyn, he had 13 trunks filled with pictures, graphs, equations, write-ups, notes, you name it. And they were all stored there. And when he died, apparently, I forget the name of the organization. It was not the FBI. It was something to do with immigration or associated with immigration. They supposedly got a hold of that stuff from the warehouse and went through it to ascertain what was really there. And, of course, nobody knows what happens behind closed doors. Some of it did go back to the Tesla Museum in Serbia or wherever it is. No, it's in Yugoslavia. Some of it vanished. Now, you know, when stuff like that disappears, it's not because some junk man decided to sell it for scrap paper. You know, it was already in the authorities' hands, and somebody grabbed it. I can't tell you who. I can't tell you what was in it. But I do know that it wasn't that long after all of that happened that certain things began to surface that kind of had Tesla's fingerprints on it, you might say. And one of them, which is the most obvious, was I think during the Reagan administration when the whole Star Wars initiative came about. You know, that was involving lasers and death rays and all kinds of stuff, which, of course, the general public knows nothing about, but which Tesla had talked about while he was alive. So I wouldn't be surprised if some branch of the government got a lot of that stuff, but it had nothing to do with me and my investigations. I was much more interested in understanding the fundamentals that the guy used to make these departures from standard physics into the things that he was able to do. So that's where I spent years. That and also tracking down, you know, basic information that disclosed different people he worked with and different people that claimed to have known him. And, you know, I just followed up on every detail that I could dig up, basically.
Wow. Well, I want to ask you a couple more questions before we wrap this up. Going back to what you were saying earlier about some of your teachers and the mind-blowing things that you learned, who were some of your greatest teachers, and what are some of the most mind-blowing things that you've learned over all these years of your research?
Well, the first teacher that I have to give credit to was actually Dominic Lucchesi, because he set me on a path that led to all this other stuff. And he was a fantastic guy. And he worked for Bendix Corporation, and he was actually an engineer that did work on gyroscopes and what do you call it, directional mechanisms and things of that sort. But in addition to that, he was into everything. I mean, we literally talked on every subject imaginable, from Tesla and Otis Carr to witchcraft, demonology, vampires, psychic chemistry, you name it. It just covered the whole gamut, and he knew about all that kind of stuff. Unfortunately, he died rather young, and I really miss him. He was a wonderful friend. So he was kind of my first mentor in that respect, not a technical respect. But then the next guy that I got to really give credit to was Gene Carini, because he opened my eyes to so many things. Even though he didn't know how to do them, he knew they were there. He knew what was going on. And he had an incredible and undying interest in all these different things. And I'd be an absolute liar if I didn't say that he really influenced my life. But as far as technical people are concerned, I had a lot of teachers. I mean, one of the first guys was a fellow by the name of Ben Dowick. And he was a motor repair guy in Jersey City that took me under his wing when I was in grade school and showed me how to motors and fix motors and take them apart and do all that kind of stuff. And he was also the first guy that let me do any lathe work. So he was kind of like my introduction to machining. And by the time I was out of high school and working for Carini, I mean, I built all his prototypes. So I could run a lathe, a milling machine, grinder, all kinds of stuff. The second guy that really was a mentor for me was when I was working for a company in North Arlington, New Jersey, and his name was Edgar Bars, and he was the most fantastic machinist I ever met in my life. I mean, I've met better ones since, but he was amazing. I think he was Lithuanian, and he taught me the basics of really precision machine work, building gearboxes and doing all kinds of things. We worked in a research lab together. I was the electronics guy, or one of them. There were actually three. And he was one of the machinists. There were two others also. So I have to attribute him to, you know, being a mentor of a special type. Naturally, I had some teachers that were very instrumental in training me. I took 2 years of college physics in high school, and my physics teacher was a guy by the name of Brother Christian, who taught me at Mount St. Charles Academy in Rhode Island. And I learned a lot of physics from him, and I really, really miss the guy. I think he's long dead now. So that was another mentor that I had. In the engineering world, I had, let's see, there was a guy who taught me programming and gave me the freedom to design all kinds of stuff for him. And his name was Harold Hattersley. And he was the head of the product development department in a company called, what the heck was the name of the company? It'll probably pop into my head, but anyway, he taught me a lot of stuff, and I designed equipment for him in the wire drawing industry that wound up all over the world, in the Middle East, in South America, in Japan, all over the place, and I also did all the programming for that type of stuff.
Wow, so you know programming too. You have a very diverse skill set.
I know old-fashioned programming because it's changed a lot since then, you know, but it's all ladder logic in one way or another. When I had my own automation company, which is a chapter we didn't explore, I was building automation systems for tugboats and oil barges and stuff like that in New York, Boston, and Baltimore. And I did all my own programming. I even designed all the equipment and installed it on three separate fleets of tugboats and ships. So I was pretty good at it. Yeah, those are all wonderful talents that, you know, you learn over the years, and I still got it if I need it. You know, it's right in there. But the finest person I ever had and still have for a guy who helped me more than anybody, he's been my best friend and in a lot of ways my mentor, especially in mathematics, is a guy by the name of George Hamill. And he is astounding. That man can do things that human beings have already forgotten how to do. I mean, he is a tool and die engineer. He's a process engineer. He's a manufacturing engineer and one of the wildest, most amazingly talented mathematicians I've ever met in my life.
Wow.
And we've been working together for almost 50 years.
Amazing. Well, I guess the last question would be, what's something that you've learned over the years that's blown your mind more than anything else?
Oh, that's a heavy question because that's going to take a whole other couple of hours to answer. But let me put it to you in a very simple way. Okay. One of the things that I have learned has to do with the subject of impedance. I read an article years ago. I believe I was a sophomore in high school. And since I lived in Jersey City, I used to take the subway over to Manhattan, and just a few blocks away from where Tesla had his office was the New York Public Library. And so they had oodles of stuff in there concerning Tesla. And I used to go over there sometimes in the evenings when I had nothing to do, or certainly on Saturdays and sometimes even Sundays. And I would just go through newspaper articles, magazine articles, any kind of book I could find. And I eventually had a file that was over a foot thick just on obscure articles published about Nikola Tesla by all kinds of different people, especially the newspapers. And in one of his birthday interviews, I don't remember what year, he made a statement that was totally amazing to me, because I already knew enough about physics and electronics to understand the implication of the remark. Somebody asked him why he got such different results from his calculations. And by the way, before I get into that, I just want to make a quick statement. There are people who are actually stupid enough to think that Tesla was not a mathematician. I am here to tell you that if you explore the schedule that he had when he went to university, the subjects that they were teaching then, they don't even teach anymore. And it involves such complicated mathematics that there's no way he could have become an electrical engineer without it. So anybody who thinks that Tesla was just a dreamer who didn't know any math is an idiot. And I'll tell you that right now, and I'll tell it to you with annoyance, because I've heard it stated too many times. But anyway, getting back to this impedance thing, somebody asked him why it was that he had such different results when he calculated impedance from the way, and not only impedance, but other things, from the ways in which we do it in the modern engineering world. And his answer was very profound. He said that the tendency nowadays is to take an electrical function, to calculate its RMS value, and then work with the RMS value, which represents a single number that is the historic time average or statistical average of whatever the function is, and it makes everything so simple. But he said it also denies you all of the more intricate information having to do with the more subtle structures that are involved with doing it the old-fashioned way. And when I found out what the old-fashioned way was, I was amazed, because what Tesla used to do was to do all of his work in algebraic and in trigonometric functions, which then went directly into the calculus. And what he got out of the calculus at the very end, he then applied to RMS figures. And so it was so hard to understand what that really meant. But I could tell by the way it was written in his own words that there was something gravely important about that. And I've been working on that off and on for many, 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 many years. And it was only with George's help that I actually eventually cracked it. And it just, I mean, I can't possibly describe it now, but basically what it has to do with is using trigonometric expressions for impedance and other qualities which are customarily manipulated with single value numbers. And the fine structure is totally eliminated. As a matter of fact, it's so bad that in the modern teaching of electronics, they refer to such things as capacitors, inductors, and a few other things as passive components, because all they do is sit there. And nothing could be further from the truth. And if you understand what he was doing with that, that's the only way that you can ever get propelled into all of the information which died with him. But you have to have balls enough to spend the years that's necessary to have trust in what he said as far as its importance is concerned, and then have the wherewithal to apply yourself endlessly until you get the answers. So those are the kinds of things that blow my mind, because the poor guy was correct, and what he could have given to the world was beyond comprehension compared to what he actually gave to the world.
Wow. Well, Jim, you are a fascinating person. Before I go, is there anything any direction you want to point people towards, any websites or any last words?
No, not really. I don't believe in blowing my own horn necessarily, but I think that eventually, before I kick the bucket, I would somehow like to be inspirational in getting other people on this track or these tracks, because I'm not going to be able to do all this kind of work in one lifetime. It's impossible. It's taken me, since I'm 19 years old till now, just to understand the fundamentals, for God's sake. It gives you some idea of the type of genius that we're really talking about. And what really pisses me off is when they compare Nikola Tesla to Thomas Edison.
Tell me about it.
Give me a freaking break. There is no comparison. Now, the thing about Edison, which I do give him credit for, is that he was incredibly well connected with higher finance, and he was a good businessman. But even he screwed Tesla.
Yeah.
So,
well,
you know that story, right? When he first came to this country, he worked for Edison, and one of the jobs he gave him was to redesign all of his dynamos and DC motors to upgrade their efficiency, and Tesla actually did that. And what Edison had promised them was a $50,000 bonus in cash if he succeeded. And not only did he succeed, but he succeeded beyond everybody's wildest dreams. And when he went to Edison for his bonus, he was refused that money. And what Edison said to him was, and he put his hand in a very condescending manner on his shoulder and said, "My dear young boy, you misunderstand the American sense of humor."
Oh, gosh.
Yeah, so I didn't have a whole lot of respect for Mr. Edison, I'm sorry to say.
No, I'd have to agree with you.
Well, there's something definitely wrong with the younger generations. I don't know what all this modern crap has done to their minds, but it seems to me that between virtual reality, cell phones, electronic games, and whatever else they're doing, it has changed people considerably. They're more introverted. They're less interested in anything. I mean, when I was a kid, even my buddies that I grew up with, They weren't necessarily doing the stuff I was doing, you know, but everybody was building hot rods. You know, they were playing around with different things like model airplanes and rockets and, you know, just all kinds of stuff. It was a totally different time in the history of the United States, and the forces that were operating were vastly different. Did you ever see that movie? What the hell's the name? October Sky? Well, the same passion that was expressed in the guy that played his part, okay, was so typical of the people I grew up with. I remember in my first science fair project, my project, and this was in high school, was a linear electron accelerator that I built myself. Yeah, well, that's what it was. And I remember when my thing was published with all the rest of the ones that were in the National Science Talent Search, I got a copy of that magazine. I had it for years. I don't know where it is now, but probably somebody threw it away. But there were so many kids doing amazing things. And I remember there was this, well, I remember people building oscilloscopes. I remember people building digital computers. I remember this. The one that I remember the best was this really attractive girl that looked like she was maybe Italian or Greek or something. She had those features, and she had a really thick pair of glasses on, and she was very cute. And she built a Van de Graaff generator and associated particle accelerator for producing electron beams. And she was a little bit younger than me. And I had all these fantasies about marrying her, you know. But, I mean, it was just so common in those days to find people doing all kinds of stuff. Ham radio operators, people doing stuff in electronics in their basements. I mean, it just went on and on and on. Now, nah, nobody wants to be bothered. Yeah, well, not only that, but, I mean, there's some kind of phobia involved that, like, once you're brainwashed by an institution like, let's say, MIT or something, you treasure that brainwashing because you believe in it and you paid for it, and it gives you a certain amount of prestige. And for you to turn around and say, oh, well, here's an exception to the rule, or this part's not correct, or whatever, it'll never happen. I don't know what that's called in psychology, but in my world, it's pathetic.
Yeah.
Because the whole venue of science is to seek the truth, regardless of where it takes you. And they don't do that anymore. So you take it easy and let me know how you make out.